My little bits are here. So earlier this year, I participated in a workshop organized by Shapeways and Little Bits. The objective of the day was to bring some everyday objects and improve them using Little Bits and 3D printing. I worked together with Maren Fiorelli and Mason Umholtz, who brought a toothbrush and toothpaste. I brought a music box. We were selected to be finalists in the ShapeBits competition that Shapeways and Little Bits were running together, and we're giving some bits and some 3D printing credits to improve our design. The purpose of our design is to give people an incentive to spend the full recommended 2 minutes brushing their teeth. We encourage this by having the music box play a tune while the brushing continues. When the music stops, the brushing is done and a CloudBit connects to the internet to update a spreadsheet which puts away a small amount of money every time to save up for a self-defined goal. The first thing I did when I received the bits was to reorganize them a little to make the circuit more compact and efficient. The circuit originally used a DC motor a little bit, but this was a little underpowered to drive the music box the way I wanted. I found a more powerful DC motor that was better suited for the job. I 3D printed a bunch of gears to choose from, so I'd be able to get the perfect gear ratio to drive the music box. As you can see here, the gear meshes with those in the music box quite nicely. Now there is no Little Bit to actually drive a bigger motor like the one I selected. Luckily, Little Bits provides a blank bit that can be used to add some custom circuitry to the design. I picked a L293D H-bridge and an external 12-volt power supply to provide control over the bigger motor and soldered together the parts to link everything up.
Stay with me, struck me by the hair, 'cause I would give anything.
And as you see here, it drives the motor. The final step in the electronics was to rearrange all the parts to make them fit in a small surface area. I used a couple of wires to make everything fit on a single Little Bit space plate. To give you a quick run through of the circuit, power comes in through a USB connector. It is routed to a button on the other side of the board. When the button is pressed by the toothbrush, it is latched high by the timeout bit, which activates the motor that drives the music box. After the timer set on the timeout bit has expired, the music stops and an inverter sends a high signal to the cloud bit. The cloud bit then communicates with an if this then that recipe, which updates a Google spreadsheet. Now that all the elements are in place, they need to be housed in an enclosure that holds everything in the right spot. I designed everything in Rhino 3D. I started by modeling the physical parts and the critical dimensions of mounting holes and gears. In order to limit material usage and therefore 3D printing costs, I created a strong yet light structure, the skeleton of the product. It finally ended up looking like this. I also designed a more aesthetically sleek cover made out of white ceramic and gold-plated steel. These are all materials that Shapeways offers to 3D print in, but for the time and cost constraint, I stuck with just the nylon skeleton for this prototype. When I got my 3D print back from Shapeways, all the physical parts lined up to fit in their places perfectly. And when you finally put everything together, it looks something like this.